Hello and welcome to the first day of Unit 13. This is the trigonometry unit. This one's kind of a long one. There's a quiz in the middle of the unit that we'll get to after spring break. But we're starting with talking about angles. And trigonometry really is all about the study of angles and triangles. Okay, so it's just some vocabulary to start you out with. Um, an angle has an initial side, a terminal side, and we talk about being in standard position. So if I come down here, here's a set of axes. If I draw an angle on here right now, so let's say right here, we draw that angle. Okay, so you're going to see me normally drawing angles on a graph like that. And when it says initial side where the angle begins, usually the positive x-axis, we usually start on the positive x-axis over here. So you can label this initial side. And that's nothing special because every angle starts there. The terminal side is the important part. That's where the angle ends. So this over here would be the terminal side. Standard position just means an angle whose vertex is at the origin, which is what this is, and whose initial side is on the positive x-axis. So we've got an angle in standard position right here. Coterminal angles I'll come back to later. That's any two angles drawn in standard position that have the same terminal side. So basically they're going to end in the same spot. A quadrantal angle is any angle whose terminal side falls on the x or y axis. So here I ended up kind of in the middle of a region, but if I ended on one of these axes, that would have been a quadrantal angle. Okay, so now usually I label an angle. You could use x, y, whatever, some variable, but the most common one is a Greek letter that almost looks like a zero with a little slash through it, a cracked egg. That is called theta. And you're going to hear me saying that word a lot, so I want to make sure you knew what I was saying. So theta is a Greek letter, kind of like pi is a Greek letter or whatever, but just another thing that they commonly use to refer to angles. And when you talk about degrees, you know some of this already. So let's talk about that. This is going to be 0 degrees. This is where I start. Think of this like a circle. If I go all the way around and end back at 0, how many degrees did I just take? 360. So if I go all the way around, I get 360. So what should halfway around be? 180. And halfway between 0 and 180 would be 90. And you can think of that as a right angle. If I went straight up, that's a right angle. So it should make sense that this is 90 degrees. And then what do you think this one down here would be? Well, it's halfway between 180 and 360. So add 90 to 180, you get 270 degrees. Now, another way we talk about it is by what quadrant we land in. So the quadrants, this is quadrant 1 in the upper right. Then we go clockwise or counterclockwise around. So this is quadrant 1, this is quadrant 2, this would be quadrant 3 down here, and this would be quadrant 4 over here. Now we'll come back to this idea about radians in a second. But radians are basically just another way to measure angles. Angle rotation, a positive angle starts at 0 degrees or 0 radians and rotates counterclockwise, which is how I drew this angle. This is a positive angle, and you go counterclockwise around, so opposite of the way that the hands on a clock moves. A negative angle, whether it's in degrees or radians, rotates clockwise around. Okay, so if I start in standard position like I always do, but went clockwise around. So if I ended up over here, that would be, I could call that negative theta. And in this case, I land in quadrant 3. Okay, so now let's talk about radians for a second. This, just like this is 0 degrees, this is 0 radians. And think about it as a circle again. If I go all the way around a circle, and remember this formula for circumference? Well, actually, before I get into this, I'm getting ahead of myself. Go to the next page. We'll come back to this. Let's talk about what is a radian. So by definition, a radian is the angle needed so that the length of the intercepted arc is equal to the length of the radius. That might seem like a kind of weird definition. The angle needed so that the length of the intercepted arc equals the length of the radius. Radian kind of sounds like or looks like radius, and they're closely related. So in this picture I have up here, what's the radius? Well, the radius would be whatever that distance is right there, right? We'll call that r for radius. Now that distance I could easily measure. If I had a ruler or something, I could figure out how long that is. We don't usually measure curved distances, but you could. And if I was in class, I would take a piece of string and measure out the length of this piece right here, and then bend that string along the circle so that I get the same distance on the arc of the circle. So let's say if I do that, let's say this distance right here is also r, the same as that distance of the radius here. So the angle that I made, if I make this angle that cuts off right there, that angle right there is defined as 1 radian. And again, that's what a radian is. It's the length of the intercepted arc from the angle is equal to the length of the radius. So it's kind of just another way to talk about it. Degrees you're all used to. You know, if I say 180 degrees, we're over here. You know, if I say 225, we're down here somewhere. It's just another way to measure it. And it turns out that it's a little bit nicer to do that when we start dealing with actual problems because radians are just real numbers. Degrees are kind of, you know, like feet or inches. It's a unit of measure. But radian is just a real number. So it's a value that we can use to solve real world problems better. So this chart down here, number of radii in arc length. So an arc length that has 1 radius long, like this one I drew up here, the angle that cuts that arc is 1 radian. If I had 2 radii long, so if I had this yellow piece and that same yellow distance again, I'd probably end up over here somewhere. That would be 2 radians. If my arc length is 3 radii, my angle is 3 radians. You get the idea. 4 radii long would be 4 radians. 5 radii would be 5 radians. 6 radii would be 6 radians. Now let's talk about what would happen if I went all the way around the circle. How many radiuses or radii would that be if I went from here all the way around and ended there? Well, Do you remember from geometry, what's the length around the edge of a circle called? Circumference. What's the formula for circumference? Some of you might be thinking pi d, but I want it in terms of the radius. So one formula for circumference that you should have seen at some point is 2 pi r. That literally means if I go all the way around the edge of a circle, I have 2 pi radii. So if I have 2 pi radii all the way around the circle, then the number of radians in an angle that goes all the way around is 2 pi radians. And we're going to be able to use that to figure out all the conversions. If 360 degrees is the same as 2 pi radians, then that means what would equal pi radians? Well, half of 2 pi is pi, so half of 360 degrees is 180 degrees. So 180 degrees is pi radians, and that's going to be the big conversion that's going to help you remember how to convert between them. All right, so flip back to that front page real quick. Let's draw this out again. We said all the way around is 2 pi. So if I go all the way around, I get 2 pi. So if you just go halfway around, or 180, like we just saw, that should be pi. So what would make sense for 90 to be? I'm halfway between 0 and pi. Right, 1/2 pi, or pi over 2. And how about halfway between 1 pi and 2 pi? Right, you could say 1/2 pi, or 3/2 is 1/2, or we say 3 pi over 2. So at least for the foreseeable future, whenever we draw these graphs, I'm going to want you to label either in degrees like this, which should be easy, or radians. And the reason I want you to label every single time is because I want you to get these stuck in your head so that you know these like the back of your hand. All right, so let's flip ahead. And this is what we're really going to be focusing on today. We're going to be practicing sketching angles. And we're going to start with degrees, which I think should be pretty easy for most of you. Sketch each angle in standard position. State the quadrant the terminal side lies in. So this is how I want you to do the homework tonight. If I ask you to graph a 30-degree angle, I want you to start by drawing that out. And even though it's tedious, I want you to do 0, 90, 180, 270, and 360. Write that out every single time. Label your quadrants, and I'm going to make fun of you and take off on tests and stuff if you don't do that. All right, so 30 degrees, nothing too crazy. You always remember you start on the 0 positive x-axis line, and my terminal side has to end at 30 degrees. As long as you're in the right quadrant, that's all I care about. I mean, technically 30 should be closer to 0 than it is to 90, but all we care about is the quadrant. Label your angle like this. You can practice writing that theta thing in there, and then state the quadrant the terminal side lies in. This would be quadrant 1. And that's it. Okay, number 2. Start by labeling 0, 90, 180, 270, 360. Angle's going to start over here as it always does. And in 225, since it's halfway between 180 and 270, I'm going to land over here. Remember, positive angles start here, rotate counterclockwise around. So that would be theta up here. And I end in quadrant 3. Because remember, it goes 1, 2, 3, 4. Okay, negative angle. Now, as soon as you see a negative angle, what does that mean to do differently? Negative angle means we have to rotate clockwise. So I'm going to still call this 0, but then this is negative 90, negative 180, negative 270, and negative 360. So negative 110 will end up between negative 90 and negative 180. We still start here. We end there. This time, I don't rotate this way around, that's wrong. Instead, I rotate clockwise around because it's a negative angle. We would still call this quadrant 3. Okay, negative 270, set it up. And hopefully once you write out those sides, it's pretty obvious to you where you're going to end up. Right here. And it's going to look like a right angle, but it's really not, because since it's negative 270, this is the angle that it rotated. So since it's not in a quadrant, and remember that word from the angle vocab on the front page? It's called quadrantal. That lands on a line. Quadrantal. Okay. Now, as I set up this last one on this page, you might be thinking, what's weird about 540? 0, 90, 180, 270, 360. Yeah, 540 is bigger than on the graph. So if this is over 360, we're going all the way around plus some more. How much further? How could you figure out how much further around you went? Right, just subtract 360. If I take 540 minus 360, 540 minus 360, we're left with 180. So the way I would draw this, I would say we're starting here. We went all the way around once, and then halfway around again, and I ended here. So that little spirally thing shows you how the angle would rotate around. And you would call it what type of angle? Again, it's quadrantal. Okay, so that's basically all you need to know about degrees. Any questions with those? No, I think you're good with those. Okay, so this is what's going to be a little weird for you, radians. Most of the nice radian measures that you see are going to be in terms of pi, because of that idea that 2 pi is all the way around, pi is halfway around. But I'll show you in a few days. Radian measures don't have to have pi in them. Pi are the nice angles because it divides up nicely if they're in terms of pi, but you're not always going to have pi, and we'll deal with that later. But anyways, how will I draw these? So for this first one, this is where it's really important that you label those quadrantals. This is 0, all the way around is 2 pi, halfway around means pi. This would be pi over 2. This would be 3 pi over 2. Okay, now there's different ways to think about it. One way is to kind of think about this as a pizza. So if you picture a pizza on here right now, pi divided by 3. 0 to pi, the top half of the pizza has a radian measure of pi. So if I divide that in thirds, do the same on the bottom, how many pizza slices would you have? You'd have 1, 2, 3, 4, 5, 6. So I'm thinking, here's how I'm dividing it. So if you look at all the red lines, 1, 2, 3, 4, 5, 6. Pi divided by 3 means there's 3 pizza slices. So if you have 1 pi over 3, you have 1 pizza slice. So your angle would be right there. And you would say that's quadrant 1. So if you want to think about dividing it by pizza slices, that's one way to do it. So if I have 2 pi over 3, 0, pi over 2, pi, 3 pi over 2, 2 pi. 2 pi over 3 means you have these same pizza slices, 3 on top, 3 on the bottom. 2 pi over 3 means I would take 2 pizza slices, 1, 2, so you'd end up in quadrant 2. Okay, so the pizza slice way is all fine and good, and you can definitely use that if you're visual like that. I like numbers better, So this is how I do it. This is how I'm always going to do it. I notice that this is over 3. So I need to think of in terms of 3's. So what's pi in terms of something over 3? It's 3 pi over 3. Does that make sense? Because 3 pi divided by 3, 3 divided by 3 is 1. Same as pi. I'm essentially getting common denominators. So what would 2 pi be as a number over 3? Well, this is 2 pi over 1 right now. Multiply top and bottom by 3. This becomes 6 pi over 3. So 6 pi over 3 is equal to 2 pi. I want 2 pi over 3. So it's between 0 and 3 pi over 3, because 2 is between 0 and 3. Is 2 pi over 3 closer to 3 or closer to 0? It's obviously closer to 3. So you're in quadrant 2. And that's your answer. So I always rewrite pi and 2 pi in terms of whatever angle I'm over, or whatever number I'm over, and then decide which one I'm closer to. So let me do that with these next couple. 4 pi over 3. So this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember to label those every single time. Think about it for a second. What quadrant do you think you're in? If you want to think about it in terms of pizza slices, I would take 1, 2, 3, 4 pizza slices. So the 3 on top plus 1 more puts me in quadrant 3. Or my way, I would say this is 3 pi over 3. And 4 pi over 3 is just 1 more than 3. So if I go 1 past 3 pi over 3, I end up down here. Label it as theta, and say you're in quadrant 3. Where's 5 pi over 3 going to be? Label it. You can think of it as 5 pizza slices, or you can say this is, I'm over 3, so this is 3 pi over 3. I gotta go to 5, which is way past that. 2 pi we said is the same as 6 pi over 3, because 6 divided by 3 is 2. And 5 pi is just 1 before 6. So if I'm 1 before that, and I was rotating clockwise or counterclockwise around, I would end up right there, and I'd be in quadrant 4. Okay, now some people get these radian idea or this radian idea really quickly, and it just makes sense and it clicks. For some of you, it might take a little more practice. I'm going to be pausing before I tell you my answers to the rest of these to see if you can figure out which quadrant you're in. So this one's different, 3 pi over 4. So I'm not over 3 anymore. All these other ones have been something over 3. But label all your quadrants. This should get tedious after a while, and that's good because I want them in your head. So think about it for a second. Now it's 3 pi over 4. Which quadrant do you think I'm going to end in? If you said quadrant 2, you're right. Now this time I'm over 4. So I want to think of pi as 4 pi over 4. What would 2 pi be, just for practice? 8 pi over 4, because 8 divided by 4 is 2. And we want to be over 4. 3 pi over 4 is just 1 before 4 pi over 4. So if I'm 1 before 4, I'm in quadrant 2. There's my angle, and that's my answer. You could also think of dividing this up into 4 pizza slices. 1, 2 in the first quadrant, 2 in the second quadrant. So if I took 3 of them, I'd end up in the second quadrant. Okay, number 11, you see a negative. What's that mean? Clockwise. So this is 0, negative pi over 2, negative pi. Pi and negative pi would be in the same spot, just like 180 and negative 180 are. Negative 3 pi over 2, and all the way around clockwise is negative 2 pi. Think of yourself as being over 4 again. So this would be negative 4 pi over 4. All the way around would be negative 8 pi over 4. Remember, I'm going this way around this time. What quadrant would you be in? one's also quadrant 2. You have to go clockwise, negative 4 pi over 4, plus one more. It's 1 past 4 pi over 4. And remembering it's negative means you're going clockwise around, so I will go this way. That's theta, and I'm in quadrant 2 again. All right, now something just happened with those last two examples. They look exactly the same. If I didn't draw these arrows in and didn't write the numbers on the end and just had the blue lines and the red arrows, they would look like the exact same answer, because this initial side and the terminal side are in the exact same location as this initial side and this terminal side. If they have the same terminal side, they end in the same spot. That was another one of those vocab words from the front. And remember what it is? Well, makes sense. They're called coterminal. Coterminal because they have the same terminal sides. So angles that end in the same spot are coterminal. All right, last page, almost done. 11 pi over 6. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Take a minute and think, where would 11 pi over 6 be? Did you say quadrant 3? If you did, you'd be wrong. Sorry. What would you want to think of pi as? Pi is 6 pi over 6, because I'm over 6 now. It's all about what numbers on the bottom. We're kind of getting common denominators. So 11 pi over 6 is way past 6 pi over 6. What would 2 pi be? It's 12 pi over 6, because 12 divided by 6 is 2. So that's equivalent. So 11 pi over 6 is just 1 before 12 pi over 6, which means you should be in quadrant 4. Good job if you thought quadrant 4. All right, we're going back to 8 pi over 3. 0, pi over 2, pi, 3 pi over 2, 2 pi. What quadrant do you think 8 pi over 3 is in? Did you say quadrant 1? If you did, wrong again. We're over 3. This is 3 pi over 3. This is 6 pi over 3. So 8 pi over 3 is more than all the way around. But how much more? This is where it kind of helps to think of pizza slices again. I have 3 slices on the top, 3 more on the bottom to get to 6. I went around another time. If I had 3 more slices on the top, what would I be at? 3 is 3, 3 more is 6, 3 more is 9. So the second time around, this is 9 pi over 3. And 8 pi over 3 is just 1 before that. So the angle would go all the way around, plus a little bit more. And you're ending in quadrant 2. Nice job if you figured out quadrant 2. That was a tricky one. Okay, last one. 5 pi over 2. 0, pi over 2, pi, 3 pi over 2, and 2 pi. This one's a little bit different. When you're over 2, you're a special type of angle. And you see 2 of them already. Pi over 2, 3 pi over 2. Anytime you're over 2, it's going to be a quadrantal. This would be 2 pi over 2. What would 2 pi be? 4 pi over 2. So where's 5 pi over 2? Well, the over 2's, you can see they're just counting by quadrantals. 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So next one would be 5 pi over 2. So it's a right angle, but really you go all the way around plus an extra 90. So this one is quadrantal. All right, that is day 1 of trig. Now your next step is to do the homework. And here it is, sketching angles. I tried to give you two examples of how I want it to look. It says sketch each angle in standard position on a set of coordinate axes. Label all axes with appropriate degree or radian angle measures. So that thing I've been harping on in the whole notes, I give you examples of how I want it to look. State the quadrant of the terminal side. Now, one thing I didn't do is I would also like to see the direction you're going. So I really would like to see an arrow going this way if it's a positive angle, or an arrow going the other way if it's a negative angle. State the quadrant, but always if it's in radian, make sure you're labeling the quadrants in radian because I want you to get those in your head. If it's degrees, labeling them in degrees is good, but I want to see them labeled. Now, if you have access to a printer and can print out a blank of this, great, that's the preference. Obviously, I know you might not all have access to a printer, so if you just need to write your answers on a separate sheet of paper, do that. But send me your answers and make sure you're checking on the new answer key. There's a new answer key posted on my website, or I might have sent it to you in email also. It's really important that you're checking answer key and you tell me which ones you want me to go over so that I know which ones to go over in tomorrow's class. Good luck. Let me know if you got any questions.